All right. Okay, we are carry on with this paper. February, March 2024, 970242. We have done this question. Now we are in the midst of doing B. And work done is W equals P delta V. That's your maximum pressure, which is constant, times the increase in volume, 5.25. Calculate the final thermodynamic temperature of the gas. And we are told the pressure is constant, so we use T over V equals constant. No? Then we calculate out 416 Kelvin. Okay, we have calculated these two. Mass of gas is 16 grams. For this expansion, there is a net transfer of 960 joule of thermal energy to the gas. Calculate the specific capacity of the gas at this pressure. Right? Either small q or big Q is mc delta T. C is cross multiply. M and delta T, that take it down there. Put in your value. 960 joule. M is changed to kilogram. And then this one subtract that. Okay. Check your working. Gas is allowed to return to its starting temperature. The piston is now fixed in position. Thermal energy is supplied to increase the temperature to the same final temperature as in figure B. Use your thermodynamic to suggest and explain how the specific capacity of gas for this situation compared with that in B part 3. You want to try?
Yeah, let me pull out my let me open. Yeah, no work done is done by gas since no volume change.
No, 3 marks. You need at least 3 points.
Net change in internal energy would be the same, because the net change in temperature is same as before.
Right, that's your first law. So you want to find Q. Q is delta U minus W. Right, remember this is a gain in internal energy. There's a work done on the system. There's constant pressure. This one is no work done. Right? Heat supply at constant volume is just equals to internal energy, that's all. So no change in volume, so no work is done for this case. Same temperature change, so same internal energy. Same internal energy. Less thermal energy needs to be supplied, so C is less. Okay. So this value is less than that value. So C is less. Okay, that's how you get a 3 mark. A mass of object, 24 gram, rests on the platform. That's your mass. Platform is attached to an oscillator as shown in figure 3.1. The oscillator moves the platform up and down. That platform up and down. The total energy of oscillation of the object is 2.2 by 10 to the power minus 4 joule. That's the total energy. In one oscillation, the object has a total distance of 14 millimeter. Calculate the angular frequency of the oscillation. So the amplitude is there are 4 of them. So amplitude is 14 divided by 4. So it's in millimeter. Right? That's given in formula sheet. You can remember it. Go ahead. If not, refer to the formula sheet. That formula. Right? Total energy formula. Total energy can obtain from here. If you've forgotten the formula, put x equals to 0. Then this is your v square. So that will be omega square x naught square. And omega, just take the 2 up there, take the m down, x naught square down, and put in your value. Right? That's your m. That's that one there. That is your m. And this one is your that one. Change it to meter. Okay. 39 radian per second. The frequency of oscillation is fixed, and the amplitude of the oscillation gradually increases. Calculate the maximum amplitude of oscillation so the object does not lose contact with the platform. What should I do?
Hmm. As long as it doesn't lose contact, the acceleration must be equal to g. Right? Object lose contact when from the platform when A is just touching only just lose contact 9.81. So put it as 9.81. X equals to, don't worry about negative sign. Negative sign shows the direction only. Right? Omega square is there. So it's 6.4 times 10 to the power minus 3 meter. Amplitude of oscillation is increased so that it is greater than this value. State and explain the position in the oscillation where the object first loses contact with the platform. Yep. The object will lose contact with the platform when contact reaction force becomes 0. Should happen when acceleration downwards become equal to acceleration due to free fall.
At the top of the oscillation, where the downward acceleration first exceeds the free fall acceleration. Don't know why they say up top, bottom also can. Cannot catch up. That's the reason. The acceleration of the vibrate of the platform is greater, so that it is moving faster than the object. Object
is under acceleration of 9.81. So when it's too large, it cannot catch up. So that's where it lose contact. But these are different alternative answer given by the marking scheme. Three capacitors are connected as shown in figure 4.1. Determine the total capacitance in microfarad of the network in three capacitors. So replace this one first. Right, 45. Then C1, replace these two. Parallel, you add them up. Right, forgotten. Parallel, add them up. Series, you take reciprocal. So first replace the parallel, that one, with the equivalent capacitance. So 10 plus 20 is 30, that's your C1. Then take the reciprocal, total capacitance, 1 over CR, that's the total capacitance, 1 over C1 plus 1 over C2, that's your C2, 1 over C1. Then take the reciprocal of it. Okay. The capacitor of capacitance 45 microfarad is connected to the variable power supply set at 8 volt. The object, the output of the power supply increases so that the potential difference across the capacitor increases to 9.6 volt. Calculate the energy delta E stored in the capacitor. What formula to use?
E equals 1 over 2 CV square.
Okay. E equals to half CV square. Right? That's your half. That's your C. Change it to SI unit. Initially, is this one. Initially, is that one there. Initially, there's the final one. Subtract. So you get 6.3 and 10 to the power minus 4 joule. A sinusoidal AC power supply is connected to the input bridge rectifier. Output of the rectifier is connected to the load resistor. Complete the circuit 4.2 by adding a capacitor to smooth the PD across the load resistor. Right? There's output on the bridge circuit. So you just put a capacitor here. That's all. The variation with time of the PD V of the smooth output is shown. Determine the time constant. Okay, just choose any one. From here to here, there's the V naught, there's your V, and then look at the time. Right? That's the equation we are going to use. RC is your time constant. Right? So we are choosing this part. Doesn't mean that you can't choose other part. You can choose this part and this part. It's the same thing. Okay, so I'm choosing this part. T is this one is 11, 12, 13. So 13 minus 5 is 8 milliseconds. That is a change in time. Right? So replace the X as a V naught. And then initially is 4. During the time interval, that time interval, it has dropped to 3.2, 2.2. So give your max, round it, and calculate out. Okay, Make sure you know how to calculate the time constant and use how exponential is quite common coming out. Sinusoidal alternating power supply has a maximum of 16 watt. State the value of the mean power when the output power supply is full wave rectified. Okay, for full wave rectified is half P naught lor. So it's 16 divided by 16 divided by 2 is 8 lor. Mean power for half wave rectified, half of this again lor. Because half cycle is used only for P naught divided by 4 lor. So it's 4.0. Okay.
Okay.
An object travel in a circle at constant speed. State the name of two quantities that vary during the motion of the object. Okay. You want to try? Can?
Hello?
Yep.
Yeah, velocity slash acceleration. Like
Velocity
velocity and acceleration.
changes direction. Momentum.
And then momentum.
Velocity changes, momentum changes as well, or any of these other alternative, or can be centripetal acceleration, resultant force that changes direction. Centripetal acceleration also change. Angular displacement, right? Remember angular displacement is a vector quantity. Okay, a charged particle of mass m and charge q enters a region of uniform magnetic field perpendicular to the field lines. The magnetic field density is B, magnetic flux density is B. Particles travel in a circle of time t and radius r. By considering the magnetic force acting on the particle, show that, okay, as usual, your magnetic force equals centripetal force. And then you want T, you want V, replace the V with 2 pi R over T. Right? So V and V will cancel off. There's still one V left. So it's 2 pi R to 1 V, and then M and R, and T, and take our Q down. So cancel our R, then we get our answer. Okay. An alpha particle, the particle is an alpha particle. The period of circular motion is 2.5 microsecond. Right? Ask you to derive the equation, derive it, and then now we just apply it. Right? 2 pi m T over Q, 2 pi. Right? Alpha has 4 nucleons. And then take atomic mass unit. Right? One atomic mass unit is 1.66 and 10 to the power minus 27 kilogram. Right? 4 nucleon, 4 atomic mass unit. For atomic mass and mass of 1 atomic mass unit as your period. Alpha has two charge. There's 2 times 1.6 and 10 to the power minus 19. then you get 0.052 Tesla. The second alpha particle is in the same uniform field. It travels at a circle of radius 2r. They explain how the period of the motion of the two particles compare. Okay, how do you reason it out?
Mm.
Yep.
I think wait,
And
period of the second alpha particle is the
same
same
thing.
as the first.
We are using this
So
equation.
same as the first.
There's no R there. So B is constant, mass is constant, charge is constant. So the period is the same, independent of R. Right? Or
Yeah,
take
it does not depend on the radius, the circle.
Okay. Any comment?
No.
The speed of alpha particle is given, and electric field is applied so that this particle now moves with a constant velocity. Use your answer in B part 2 to calculate the electric field strength if you need your answer. You calculated B. So basically, we are using magnetic force equals electric force. Magnetic force is dQV. Electric force is E times Q. E is electric field strength. So Q and Q cancel off. E is PV. There's your B we calculated earlier. V is here. Right? Newton per Coulomb. From definition. Force per unit charge. That's an electric field. Okay. Okay. A small coil C has 64 turns. That's your coil. And cross-sectional area is given. The coil is placed inside a solenoid. That is your solenoid, as shown in figure 6.1. The center of the coil is at the center axis. That's the center axis. That's your coil. There's a constant current in the solenoid, constant current. Coil C is moved through the solenoid from position X to position Y. Figure 6.1, 6.2, sketch a graph, sketch a line to draw the variation of magnetic flux linkage in coil C with position as it moves from X to Y. Right? As long as it's not too outside, the field is uniform. Flux linkage is constant. Right? Uniform. Right? Anywhere. Can be up, can be down, doesn't matter as long as it's horizontal line. Explain the shape of the line. Why do you get a horizontal line? You want to try?
Mm.
Constant flux density inside the coil. Magnetic flux density is proportional to flux density.
Uniform inside the
Okay.
solenoid. Magnetic flux density is uniform inside the solenoid.
Coil C is now held stationary at X. The current in the solenoid is varied so that the magnetic flux density B at X varies from 0 to 4, right? From 0 to 40, as shown in figure 6.3. Calculate the maximum magnetic flux linkage. What should I do? Yeah.
Yeah. So phi equals BAN.
Can?
Yeah. 0.08 times 0.71 times 10 to the power negative 4 times 64.
Okay.
3.6 times 10 to the power negative 4.
Just use your BAN. That's all. And then B is the largest value. A is your area of the small point, right? Right? Change it to meter square. And then number of turns, 64 turns. Now you get your answer. On figure 6.4, sketch a line to show the induced electromotive force E in coil C from 0 to 4.0 to 40, well, time of 0 to time of 40. So you just remember that it's a gradient. Don't worry about negative sign. Don't worry about this negative sign. Negative sign is just the Lenz law. Okay, you want to consider, doesn't matter, they won't penalize you. So it's just the gradient of the B graph, right? That one, gradient is 0. That one is positive. That one is negative. Same gradient, same magnitude. Right? From 0 to T is 0. And this one is any point there. Doesn't matter where, it doesn't really matter whether up or low. And as long as these two are the same, right? E is 0 from 0 to T, right? And non-zero after T, as long as you get non-zero, you get a first point. E has a constant non-zero magnitude between 0 from T to 40, right? As long as non-zero, you get another point. E is non-zero value for one sign between, so the other one is this, one is up, one is down, one is down, one is up. Right? You want to join that, you can join that up. A metal spring pressed on the smooth table. The turns on the spring are equally spaced. The ends of the spring are connected to a DC power supply, as shown in figure 6.5. The spring is connected to a DC power supply using flexible leads. Connected to power supply there, power supply there. For 10 more minutes, that's all. The spring is not under tension. With reference to the magnetic field, describe and explain the change in distance between the turns of the spring when the power supply is first switched on. Yep.
All right.
Yep. What happened?
When the power supply switches on, this is first, wait, the current creates a magnetic field in the wire. Like it's like a right angle to the wire. The field will interact with each other due to the turns of the wire.
Current in the spring creates magnetic field around the spring. Current in one turn interacts with magnetic field due to adjacent turns. The cause force to be exerted between the turns. Magnetic force is attractive, so the distance between the turns decreases. Right? Basically, each turn, the current is in the same direction. So they will like current attract. Okay. Yeah, other alternative answer lah. Photon has an energy that calculate the momentum. What formula to use? Can remember the formula?
Turn use the yeah.
E equals E over C.
P equals E over C, yeah.
E is there is your E. C is the speed of light. Okay. Newton second. A laser has a power of 350 milliwatt. Light from the laser has a wavelength of 640 nanometer. Determine the number of photons emitted by a laser in time of 1.0 second. Okay, what formula to use?
Or what formula to use?
How to calculate?
P equals E over T. Because
Right? These are the
N
formula.
HC over lambda.
Calculate the energy by frequency or by wavelength. Right? E equals hc over lambda. That's your H. That's your C. That's your 640. Change to SI unit. Calculate out. Then P equals to NE over T. Right? And to find N, cross multiply PT over E. P change to SI unit. T is 1 second. And then E as your unit. Okay.
Yeah.
5 more minutes. Laser beam is incident normally on the surface that absorbs all the photon. Show that the force exerted on the surface by laser beam is given by F equals to PC. P is the power of the laser beam and C is the speed of light. Right? Change in momentum. F, the force is equals to change in momentum divided by time. Delta P over delta T. So our change in moment, power P is E over delta T. And then your place inside there, your momentum is P over delta T. E equals delta T over 0. Right? E over delta T equals to P. So replace that, we get 1 P over 0. Right? Momentum momentum is just E over C. And we get our answer. Okay or not?
Yeah.
Yeah, okay, let's carry on. Light of single wavelength is incident on the surface of different metal. The work function energy of the metal is given in figure 10.1. Explain the term threshold wavelength. Okay. Want to try? Explain the term threshold wavelength.
The show wavelength is the maximum wavelength of incident electromagnetic radiation that causes photoelectric emission from a surface.
Maximum wavelength of electromagnetic radiation that causes electron to be emitted from the surface. The key is surface of metal. From table 7.1, calculate the value of the largest threshold wavelength. Right? For function. We use this one. Change it to joule. 1.6 times 10 to the power minus 19. Right? Remember, you want the largest wavelength, so the lowest work function. That's what we are using here. Largest wavelength, smaller work function. Then your wavelength, right? Cross multiply. Take the pi down, take the lambda up. 6.63, that's your H, that's your C, and there's your 5. Copy out. Okay. Okay, about 1 minute left. State what is meant by binding energy of a nucleus. Yep,
Binding energy
very popular.
is the energy required to completely
Minimum
completely
energy required to separate the nucleons of
separate all the
nucleus.
nucleons in the nucleus. Yeah. I just did that.
Okay. The nucleus of uranium-235 absorbs neutron and becomes unstable. It undergoes a fission reaction. One possible reaction is given by that. Determine the number of neutrons produced in this fission reaction. How to do that? At the top there. Right, at the top there, subtract the top there. Answer is 4. Right, anytime it would cut off already. Calculate the energy released in mega electron volt in the fission of nucleus of uranium-235. Energy release equals energy of xenon plus energy of strontium minus binding energy of uranium. Right? Remember this per nucleon.